Good day, everyone, and once again we are back together, and this time we'll be looking at paper 2. I hope all of you that are writing wrote really well and that you really did your best when it comes to mathematics. Okay, paper 1, that is. Okay, so we're going to be looking at analytical geometry, and of course, during the course of the day and the weekend, I'll be giving you other material as well, just for your reference. Okay, right, let's have a look at it. Right, so they say to us in this diagram, we've got A, which is 4 and 2, B, which is 6 and negative 4, and C, which is negative 2 and negative 3, which are vertices of a triangle ABC. Right, I think we can all see that there. Okay, and they say T is the midpoint of CB. Now that's very important, right? So we need to note that, so we know that's the midpoint over there. Okay, so they say such that they say the equation rather, okay, let me just bring this down a little bit. Okay, the equation of the line AC is given by, okay, so let's look for line AC. Okay, so we know that line there is given by 5x minus 6y equal to 8, right? Now, if I were you, and what I would actually just start doing is let's find this equation. I know we're going to need it at some point, right? So let's write it in standard form. So we're just going to simply say, right, this is going to be minus 6y is equal to, if I take 5x to the other side, it becomes minus 5x plus 8, right? So that means that if I divide by negative 6, so y will be equal to, that's going to be 5 over 6x, right? Minus, remember I'm dividing by negative there, so that's 8 over 6, which would be the same as 4 over 3. So that is minus 4 over 3. Okay, right, so this is the equation of our line, AC, right? So we know the gradient should be 5 over 6. Okay, so they say to us the angle of inclination of AB is alpha. Okay, so there they've indicated the angle, and DCT is drawn such that CD is parallel to BA. And that's very important. So we know that the gradient of these two, right, of these two lines, they've indicated them to us. So the gradients there should be equal, right? They say the lines AC and DC intersect at S, and the y-intercept of AC, right? So they say PF and R are the x-intercepts of DC, AC, and AB, respectively. All right, let's get right into the question. Right, so the first question is calculate the gradient of AB, right? So we've got our points there for AB, which is A is 4 and 2 and B 6 and negative 4, right? So I'm going to write that down there. That's 4 and 2 and B 6 and negative 4. That's what we have for our gradients, for our points there, right? All right, so we're looking for the gradient of AB. That's very straightforward. So we know that that's going to be y2, or rather, let's say yb, right, minus ya over xb minus xa. Okay, and in this case this becomes yb, that's going to be negative 4 minus ya, which is minus a positive 2, right? Remember, this 2 becomes positive. Okay, and then xb, which is 6 minus the a positive 4, right? And please be careful when you are calculating the gradient. Okay, there already is this negative sign. That's what I was trying to say there. So that will give us negative 6 divided by 2, right? 6 minus 4 will give us 2. and so it means that the gradient is -3. And please be careful, ladies and gents, all the time when you're calculating the gradient, make sure, remember, positive gradient is a gradient that is increasing as you move to the right, like this. We use the right hand tick, and negative gradient looks something like this. So when we go back to our drawing, right, when we are looking at the line AB, it does seem that that line has got a negative gradient. So that's very important. Okay, so you need to always look out for that. Okay, then the next question says calculate the size of alpha, right? So we're looking for the angle of inclination. Okay, let me just label those. So that's 3.1.1 so that we know which one we're working with. Right, so on 3.1.2, we're looking for the angle of inclination. Right, so we know that the tan of alpha, okay, is equal to the gradient. But remember, in this case, because it's a negative gradient, there's going to be something that we need to do in that case, right? So we're going to say, right, so the tan of alpha is equal to -3, so that's equal to the gradient of AB. So alpha is arctan of -3, and let's just quickly do that. So let's shift the tan of -3, and that gives us -71.56. Now, please remember, when you get an angle like this, especially when you've got a negative gradient, right? What it's actually giving you, it's this angle over this side, okay? Because that's where 10 is negative if you think of the Cartesian plane, right? So what we need to do, remember, when you do general solutions for 10, you always say plus 180k. So in this case, what I'm going to do is just say it's plus 180, so that it actually gives me this angle over there. Please keep that in mind when you are finding so alpha is actually equal to 180 minus 71.56. Okay, and in this case, all right, because it should have been 57, isn't it? Yeah, so let's fix that. Let's say 57, so that we are as accurate as possible. Right, so that's 180 minus 71.57, and that gives us 108.43. All right, so we keep that in mind. What I would like to do, ladies and gents, is just to go back to my drawing and try to, just populate as much as I have, right? So we already know the gradient here of AB is -3, right? And I know that this angle alpha, we said, is 108, so that's 108.43, right? Okay, so let's go back. Right, the next question says calculate the coordinates of T, right? So quite straightforward. We've got both B and C, right, which is -2 and -3, and B is 6 and -4, right? Okay, so that's number 3.1.3, right? So that's 3.1.3. So we've got C, we said that's -2 and -3, okay, as well as we've got B. We did say that B is 6 and -4, right? So we're looking for the x value at T. We know we're going to say, well, it's xB plus xC, the x value at C, divided by 2. And we know that for the y value at T, we're going to just use our midpoint formula. That's going to be, YB plus YC. And it wouldn't matter even if I started with B or C in this case, right? So that's going to be, so I said xB, which is 6 minus 2, okay, for the x value, and divide by 2, and I get a value of 6 minus 2, which is 4, and divide by 2, that gives us 2. So the x value at t is 2, and the y value at t, in this case, we're just simply going to take our y values. So that's minus 4 minus 3, right? And that divided by 2 there. And so that will give us negative 7 over 2, or you can say 3.5 if you want to. So that gives us 2, right? And y is negative 3.5, or you can say 7 over 2. Right, ladies and gents, please remember, in this case, I don't know why did I write it like that. So t is actually 2 and negative 3.5. Okay, there the value is y is negative 3.5. Sorry about that. All right. Okay, so let's go on to the next one. These are quite straightforward. I'm sure all of you, know how to obtain that. Now we want the coordinates of S, right? So remember, S is the y-intercept, okay, of that line there, which is AC. And remember what we've already done. We've already found the equation of that line, right? So we said it's 5 over 6x minus 4 over 3. So already this is our C value, the y-intercept, okay? So we'll just simply say this is 3.1.4. We already have the equation there. That's y is equal to, we said that's, I forgot that equation, 5 over 6x minus 4 over 3. All right, so that's 5 over 6x minus 4 over 3, right? So therefore, it means that the coordinates in this case of S, which is the y-intercept, would be 0 and negative 4 over 3. And please, ladies and gents, please do get into the habit of just checking those values, right? If they correspond with what you get there, is it on the y, or rather the negative y values? Do I expect a negative y value at S? And the answer is absolutely yes, right? So in that case, it does look like it is accurate, right? So that's 4 over 3. Right, now they say to us, determine the equation of CD, right, in the form y is equal to mx plus c. Right, so we're looking at CD, right? Now, what do we know about CD? We already know that it is parallel to AB. So meaning we can already tell that the equation should be negative 3x plus whatever the y value, let's say plus c, right? So in this case, all we're going to do is, we know it passes through that point, negative 2 and negative 3, right? We can obtain the y values there, right? So, okay, that's 3.2. Okay, so we know that CD is parallel to AB, right? So in this case, it means that MCD would be equal to MAB, which is equal to negative 3, right? So we already know the equation, minus 3x plus c, and in this case, we're going to substitute, all right? We're going to substitute, I'm not sure what's happening with my English. So we're going to substitute the point there at c, which is negative 2 and negative 3, right? So let's do that. So when y is negative 3, x would be negative 2, okay? And c value, what do we get there? So we'll get negative 3 times negative 2, which is going to be positive 6. But when I take it to the other side, becomes negative 6. So negative 3 and negative 6 gives us negative 9. Okay, right. So it means that the equation is going to be y is negative 3x minus 9. And that's the equation for line CD, right? Okay, let's go on to the next question. All right. They say to us we've got y. They say calculate the size of DCA, right? So to get the size of DCA, so this is angle DCA. Let's go to that. So this would be angle DCA. Can you see that? All right. So they want the size of DCA. Right. Now I'm going to actually make a plan because I don't have much information around that region. But I want you to think about it, ladies and gents. And this is something you always need to keep in mind when you're working with analytical geometry. It still is geometry, right? So when you look at that angle there, DCA, can you see that it would be equal to this angle here, right? Why? Because of alternating angles, right? Remember, those two lines are parallel. So as a result, it means that we've got alternating angles. Now, I'm going to remind you of something, right? Would it be possible for us to work out what this angle is? Yes, we've got the gradient there. Our gradient is 5/6, so we can find out that angle. Let's call that angle theta, okay? Just for argument's sake, right? So in this case, what would happen? We know in the triangle AFR, right? It means that angle theta there plus this angle over here, which is FAR, right? This angle over here, right, would be equal to angle alpha. Why? The external angle of a triangle, right? So in this case, we've got the external angle, exterior rather, angle of a triangle is equal to the sum of the opposite interior angles, right? So I know these two angles put together should be equal to angle alpha. Please keep that in mind. All right. Otherwise, you could also use sum of angles on a triangle by finding this angle over here, right? So you could also do that as well. Right. So let's do that very quickly. So I am simply going to say, right, for this question, which is 3.3.1. Okay, so for 3.3.1, we said, well, let's find out what the tan of angle theta is, right? And in this case, we said this would be equal to the gradient of that line AC, right? Which our gradient was 5/6. So equal to the gradient of AC. So theta is the arctan of 5/6. And in this case, let's do that quickly. All right, so shift the 10. No, I've done something wrong here. Shift 10 of 5/6. All right, I get 39.8. 39.8. Well, let's say 81. Okay, and then now I know that the angle theta plus the angle DAC, right, are equal to, we said it's angle alpha, right? And I can say the exterior angle of a triangle, right? So in this case, to get the angle DAC, which is what we have, we wanted, that's going to be alpha minus theta. So that would give us 108.43 minus 39.81. Okay. And quickly, so that's 108.43 minus 39.81, and that should give us 68.62. So the 68.62. All right, so that is how big that angle is, DAC, right? Now, keep in mind, ladies and gents, oh no, actually I said DAC, it's actually angle FAR, right? And remember, we're finding this angle FAR over there. But in this case, what do we know? Apologies for for saying DAC. But what do we know? We know that these two angles, FAR is equal to DCA, right? Okay, apologies for that. Okay, so this would have been FAR. Okay, so that's FAR, far. FAR. Okay, so we know that FAR is equal to angle DCA, right? DCA, all right, which is what they wanted to find, us to find, which is, we know that that's from alternating angles, okay? And as a result, we've got the angle that they wanted, which is DCA, which is 60, we said, what's the value there? 68.62. So that will be equal to 68.62 degrees, right? Okay, right, let's go for the last question. So the last question, they want us to calculate the area of triangle POSC, right? So let's check, where is that POSC? Okay, so that's P, there's O over there, okay, S and C. All right, so they want us to obtain this area over here, okay, right. Now that's really up to you how you would like to do that, okay. So there are two ways in which we could do that. We could find this area over, right, we've got the angle, so I can find the area of the entire triangle PFC, right? So let's do that. Let's find the area of triangle PFC. Now, just to make things a little bit easier for me, okay, I'm also going to find the coordinates of P, right? Remember that line there is minus 3x minus 9, if you remember that. Okay, so that's y is equal to minus 3x minus 9. So we can find the x value at P very quickly, all right, by making y equal to 0. That's going to be 3x is equal to negative 9, and so x would be equal to negative 3, right? So that means this point here is negative 3 and 0, okay? That's if you're going to need it, all right? I am going to use it because I already have this angle over here, and we can find the length in this case of, let's see, I can find the length of CF. Okay, right. So remember the coordinate of F in this case. I don't think we obtained it. I don't think we found the coordinates of F. So to find again the coordinates of F, all we need to do, find the x-intercept there. Okay, so I'm going to make y equal to 0 here. So I've got 5 over 6x is equal to 4 over 3, right? If I take this to the other side with y equal to 0, and so I'll multiply both sides by 6 over 5. Okay, so that I get rid of this. But what I do on the left, I do on the right. So, sorry, 6 over 5, not 5 over 6. Okay, 6 over 5. Okay, so I'm going to have 4 over 3. okay, and multiply that by 6 over 5. All right, I get a value of 1.6, or you can say 8 over 5. I'm just going to stick with 1.6. So I know the x value there would be 1.6 and 0. Right, now, why are these important to me? Because we're going to find the length. So I'm going to find the length of CP, right? So this entire length there, right? If you don't mind, let me do it right here so that it just becomes easier for me. Okay, so the length of CP in this case would be, remember our distance formula. Okay, when we use it, we say yc minus yp, okay, squared plus xc minus xp, okay, xp squared. All right, so what I'm simply going to do, sorry for working on the diagram itself, I just don't want to lose the values as I scroll down, right? So what I'm going to say, that's yc, that's going to be negative 3 minus xp, that's 0, okay, so that's minus 3 squared, plus xc, that's negative 2 minus a negative 3, right? Remember, when I say negative minus a negative, so that makes that a positive, right? Okay, so we can get the value of CP, right? So I have negative 3 squared there, which is going to be 9 plus 1, so that gives me square root of 10. Okay, so that's the value of CP. So this length here, CP, is square root of 10. Okay, and now I want the value of CF, right? Oh, well, actually, I could have even used this side over here. It's much easier to calculate the length of that side. All right, so I am going to obtain that value of CF, right? And I mean, sorry, the value of CF, I've already committed to it. Okay, so to find the value of CF, again, the distance formula, I'm just simply going to say that's going to be XF minus XC squared plus YF minus YC. Okay, I can't write that over there, squared as well, right? So to get the value of CF, now note, this is a bit of work because I'm explaining, but I mean, of course, you guys would have done that quick, fast, and in a hurry, right? So in this case, what am I going to find? I am going to find negative XF minus XC. Remember, our X is 1.6. So we said 1.6 minus xc, which is negative 2. So that would be minus a negative 2, which is plus 2 squared. Okay, and the y value, you've got 0 minus a negative 3, which is going to give us a positive 3. So I'm just going to substitute those values, ladies and gents, for the sake of time. Okay, so now we're looking for that value. So that is going to be the square root of, that's 3.6 squared, okay, plus, we said plus 3 squared, right? Okay, right, and that gives me, okay, I don't know if I'd want to write this as, okay, let's give this a shot. So that's going to give me 4.69 units. Okay, please keep in mind, ladies and gents, if it is possible, and it's up to you, please try to only round off at the end, right? So we've got square root 10 and 4.69. Remember, when you take the area formula, ladies and gents, right, you always take two sides, and that's why I took those two sides here, and the angle in between them. Okay, so the angle in between would be that 68.86 that we found there, right? So which is DCF, right? So I'm going to take the area of triangle PCF. Okay, so let's find that area. So the area of triangle PCF, right, that's going to be half of, all right, so we said that's going to be half of CP, right, and CF. Yes, okay, so that's CP, that's CF, the sine of the included angle, right, which in this case we said is angle DCA. Right, so CP, we found that to be root 10. Okay, I'd really want to keep that in its said form, but for the sake of time, 4.69. So we said that's 4.69, the sine of 68.62. Okay, 62. And in this case, you've got 0.5 multiplied by the root of 10. Okay, multiply that. We need to make sure that we represent that correctly. 4.69. Okay, the sine of 68.62. All right, and I get a value of 6.9. Remember, this is going to be units squared, right? So that's the area of PCF, right? Now, what do we need to do? We also need to find the area in this case of, now we're going to, so we found the area of the big triangle. So I am going to subtract from the area of this smaller triangle here. Okay, let me just use a different color again. So I'm going to subtract the area of the smaller triangle over here, right? And what we can do there is find, the length, okay, of FS. We can find the value of F, and that, do we have that length there? That intersection over there. All right, and of course we do have the angle in between that. Okay, right, remember those would be vertically opposite angles from theta. We already found the angle theta over there, right? Please note in this case, so you would find the area. Okay, I'm too lazy to go through the entire process again, right? Please note, so we find the length of FS, right? We can find the length of F and that particular point over there. Okay, and in this case, then find the the area of FS. Let's just give this a name. We can call it X, right? So we can find FSX, and in this case, that is what would give us, we subtract the two areas, and that will give us the area that we are looking for, which is this area over here, right? If anyone knows of a better way that we could have done that, please do suggest, okay? But that is how the cookie will crumble in my case, right? So please have a look at these kind of questions, and please don't allow them to waste time for you, right? It's 5 marks, so you could also just make sure that you stick within the time. All right, otherwise I'll see you guys next time. Sharp, sharp.